So here's our next problem. We have a beam that we're going to be analyzing from A to C, 4 meters long, and over these 2 meters, there's a uniform load coming off of 250 newtons per meter. There's a point load of 500 newtons right here, and then this is a support beam, so pinned here and there, so that'll provide a support. And what we're asked to find is for this beam AC, find the shear as a function of x, the bending moment as a function of x, and find the maximum bending moment and its location along here. This is our usual problem statement. Here's the free body diagram. So it stands to reason that because of this support beam, this beam will be pushing in against the wall. But notice what I did here actually. This pushing against the wall. So here I have the wall pushing back. So here's AX going positive. This will want to push down. So here's the wall lifting up here. All right. So over 2 meters, I have a uniform load. So that's 500 newtons. And I drew this on the top part coming down as opposed to hanging. It's all the same. And so that would be 1 meter to that load and then 1 meter over. And then here's the presumably the weight of this beam being added in. So there's 500 newtons there. Then we go over 2 meters, and then here we have this is 3, this is 4. So this is a 3, 4, 5 triangle. So that's our trigonometry. So here's what I'm calling FC pulling up. All right. So we need to do our supports, which would be done in the usual way. So if I sum the moments at A, starting the left, which is my practice, I have 500 going clockwise, so minus 500 times 1, minus 500 times 2, that's for this piece, plus going counterclockwise, FC, the y component would be times 3/5. But that we're not done. There's a tendency just to write a force and another number and think, oh, I have a moment. No, this is just the y component we needed, and that's 1, 2, 4 out, so we multiply by 4. Okay, solve for FC, get 625 newtons. All right, now, summing forces in the y. We have AY coming up, minus 500 and 500, so I'll just call that 1,000, plus FC times 3/5 going up. We know FC, it's 625. Substituting in, we get AY is also 625. And finally, we have AX is pushing out. This is pulling back. Notice that's 4/5. That would be the X component. Solve for AX, get 500 newtons, which is fairly straightforward. Okay. So now we need to figure out the ends because we want to do a plot of what's going on here. So I have the A end and the C end. So here I have a support. AY was 500, 625. This load, distributed load over virtually no distance, is 0. So then V0 is indeed 625. This is coming down. That's for clockwise. That's good. And since this distance is virtually nothing, then there's no torque there. So MB at 0. So this is the x-axis starting from 0 going out to 4. So we have 0 Newton meters. Fine. Now we go out to the end. The y component of the force is Fc times 3/5. All right. This is an impossibly thin piece again. Here's Vc coming up, V, the shear coming up at 4. This is coming up already, so that means V4 is going to have to go down. So that'll be minus 625 times 3/5, which is minus 375. Okay, and because this is impossibly small, there's no moment created, so MB4 is also 0. Okay, and So there we have that. So now we're going to move over to our plots here, trying to get as much in the picture as possible. Let's go with that. So here we are. Initial condition, the shear initially is 625. We need to end up at minus 375. And the moment starts at 0 and ends at 0. All right. So now, the process we'd said is, so we're at 625, we're walking across the beam. So let's walk across the beam up here, and we're going to hit 500 newtons going down linearly over 2 meters. So that would take us, 625 minus 500 would be 125. And so we'll draw that in. And there we have it. Okay, now we're going to go through this force. That's 500 instantly. So 125 minus 500 is minus 375. And then we go through, and then once we pass here, we have nothing for 2 meters. And we hit our end condition. So there we go. All right. So now let's see what we have here. We have a sharp slope, and we're going to end it still as positive slope. So we have some area we need to account for here. We've got a rectangle here that's, we got 2 pieces to consider to do this. This piece here is 125 times 2, so we have area is 125 times 2 plus 500 times 2 divided by 2. Okay? And that would give us 750 Newton meters. So we're going to pick off, line these up here. And notice that the slope, this is the slope of that, so it's always positive. So I'm going to kind of do something like this. So it's still going up at a positive slope as it gets near there. All right. And now we have here, so we have this area. So that's 375 times 2. That's 750. That takes us down in a straight line. Okay. So we were asked at the top here, plot the shear as a function of x. Done it. Plot the bending moment as a function of x. Find the maximum. So max mbx equals 750 Newton meters at x equals 2 meters. And there we go. All done.